Hello everyone, welcome back. In this video, we'll be discussing about the second and the third problem of today's biweekly contest. Longest unequal adjacent groups subsequence 1, longest unequal adjacent groups subsequence 2. Both the problems are very similar, the only difference being the second problem has slightly less constraint and also it has one less actual constraint in the problem itself. So in this particular video, we will be focusing on solving the third problem majorly. But once we solve the third problem, the second problem is very trivial. So I would encourage you to solve the second problem by yourself after solving the third problem if you haven't done so yet. So with that, let's get started. The problem states that you are given a integer n and two arrays, words and groups, both of size n. You need to select the longest subsequence from the given array such that the subsequence holds the following condition. What are the conditions? The conditions are, let's say this is the subsequence I0, I1 all the way up to ik minus 1. All the adjacent indexes, the group should be unequal. So groups of I0 should not be equals to groups of I1. Groups of I1 should not be equals to groups of I2, and so on and so forth. And similarly, words of all the adjacent words should have a Hamming distance of 1. So Hamming distance between I0 and I1 should be 1. Hamming distance between words of I1 and words of I2 is 1, and so on and so forth. So we need to only consider the subsequence that holds these two criteria, and for each, like from all these subsequences, we need to figure out what is the longest such subsequence, right? So let's take an example. Let's say the words is this BAB, DAB, CAB, and groups is 1 to 2, and we need to figure out what is the longest length of subsequence that we can extract which will satisfy the given constraint. So one such subsequence is 0 2. If you look at the 0 2 subsequence, it satisfies both the criteria. So groups of 0 is not equals to groups of 2, so the first criteria is satisfied, right? Similarly, words of 0 and words of 2, the Hamming distance between these two is equals to 1 because these two characters are exactly same, only the first character is different. So Hamming distance is exactly 1. So both the conditions are satisfied, and hence 0 comma 2 is a valid subsequence. Now you can't find any subsequence of length greater than 2 or any valid subsequence of length greater than 2, and hence 0 comma 2 is the largest subsequence, and we return the answer as 0 comma 2 itself, so BAB and CAB, right? There can be multiple such subsequences of largest length. For example, in this case 0 comma 1 is also a valid subsequence, but as per the problem statement, if there are multiple answers, we are free to return any of them. So hope the problem statement is clear. Now how to solve this? What is the brute force solution? If you haven't thought about the brute force solution yet, I would encourage you to pause and try to solve, or try to write the brute force solution at least by yourself. So we need to find out the longest length subsequence which is valid. So the brute force solution could be try out every possible subsequence, right? Figure out which one of them is valid, which one of them is not valid. Among all the valid subsequences, pick the one which is of the largest length, right? So that can be the brute force solution. So how that would look like? Let's say you pick some subsequence. So in this particular case, we have this array. The first one is the groups array, second one is the words array, and let's say we take one subsequence 0 4 6 and another subsequence as 0 4 5, right? Now if we need to find out whether it is valid or not. If it is valid, then I will consider it as one of the probable candidate in the answer. So basically among all the valid ones, I will select the one which has the maximum length. So how to figure out whether a subsequence is valid or not? So let's try this. So 0 4 5, if you look at the groups array, you will have 1 2 and 1, and similarly words array AB AA and BA, right? Now in this case, the first criteria is adjacent elements in the group should not be equal. So groups of 0 is not equals to groups of 4. Similarly, groups of 4 is not equals to groups of 5. So the first criteria is actually satisfied. What is the second criteria? Second criteria is the Hamming distance should be equals to 1. So Hamming distance between 0 and 4 is 1. Why? Because only one character is different, right? Similarly, Hamming distance between 4 and 5 is also 1 because only the first character is different. So both the condition is satisfied. So this is a valid subsequence. Similarly, if you look at 046, this is not a valid subsequence because the first criteria itself is not satisfied for this particular adjacent elements. So we will figure out all the valid subsequences, and among all the valid ones we will pick the one which is of largest length here, right? So this is the brute force solution. What would be the time complexity? Time complexity would be, for each subsequence there are total 2 power n subsequences, right? For each subsequence, what you are doing, you are trying to figure out whether it is valid or not. So we are first checking the groups array. For groups array, what you are doing, you are just comparing the adjacent elements, right? So how many adjacent elements can be there? Order n in worst case. Now after that you are checking the Hamming distance as well. So for each adjacent elements, what you are doing for calculating the Hamming distance, you iterate over each of the character and see if which one are different, right? So the ones which are different, you will increment your counter for the Hamming distance. So for each adjacent string, you are iterating over all the w characters of each of the string, and in there can be n adjacent positions here. So n into w would be the work required to calculate the Hamming distance for each of the adjacent strings. So this is the overall time complexity. In the problem, words and n is 1000 and words of I dot length is less than equals to 10. So this part is very efficient, but this part will not be enough because 2 power n means 2 power 1000, which will surely not fit in the given time constraint. So we have to optimize this. Now how to optimize this? Basically, which one of this factor you will try to optimize? Obviously 2 power n, right? Where 2 power n is coming from? It is coming from the fact that we are trying out all possible subsequences and then taking the ones which are valid, right? Do you need to try out all possible subsequence? The answer is no. You only care about the valid one, right? So we have to now do some observation and apply some trick so that we only try to figure out the best subsequences from the valid ones, right? So let's think about it. From 0, where can you go? Can you go to 1? Answer is no. Why? Even though group array is different, the Hamming distance between the 0 and 1 is not equals to 1, it is 2. So you can't jump from 0 to 1. Similarly, you can't jump from 0 to 2 as well because the groups array itself is not different. From 0 to 3, it is a valid jump because the Hamming distance is equals to 1 and groups array is different as well. Similarly, from 0 to 4, it is a valid jump because Hamming distance is again 1, right? From 0 to 5, this is not a valid jump. From 0 to 6, again not a valid jump. So from 0 you can either go to 3 or you can go to 4. Let's say you jump to 3. So if you jump to 3, what you need to now do, you can simply say, okay, give me the largest subsequence length starting from 3, right? Whatever is the largest subsequence length starting from 3, you can simply append index 0 and that will be the largest subsequence that is starting from 0, right? So isn't this problem exactly similar to the original problem? Original problem was give me the largest subsequence length starting from 0. The reduced problem is give me the largest subsequence length starting from a particular index, in this case 3. So hope you can see the recursion here. So what we will simply do, we will simply have a function f, right, that will take in an index and it will return what is the largest subsequence length that is starting from this particular index, right? And we will simply try to go over all the possible next indexes, figure out the largest subsequence length from that index itself, and whichever gives you the largest length among all possible jumps, that will be your answer, right? Now let's see this in action. So one more thing, we are now trying to care about finding out the length of the largest subsequence. The original problem asks you to find out the actual subsequence itself, but for now we are just solving for finding out the length of the largest subsequence. We'll come to how to find out the exact subsequence later, right? So this is the uh, exact same array, and I just changed the mapping. I just specify the mappings. So let's say you need to find out the value of f of 0, basically the largest subsequence that you will get starting from, if you start from index 0. So if you figure out what is the largest subsequence then starting from index 0, if you figure out the largest subsequence then starting from index 1, index 2, and so on and so forth, you can take the maximum of all of these and that will be your final answer, right? Because the problem doesn't bind you to start from a particular index. You can start from any of these indexes, right? So you will simply figure out f of 0, f of 1, f of 2, f of 3, all the way up to f of 6 and take the maximum across all of them, and that will be your final answer, right? Now how to find out f of x? So let's just try to see that. F of 0, right? From f of 0, we can, from 0 you can jump to either 3 or 4 or 6, right? So if you jump like, let's say you jump to 3. Now if you jump to 3, you need to now figure out what is the largest subsequence length that will start from 3. Whatever is the largest subsequence length that will start from 3, you will just simply add 1 to that and you will get the largest subsequence length that will start from 0 if you jump to 3, right? Similarly, you will figure out the largest subsequence length if you jump to 4 and 6, and you will take the maximum across all of them, and that will be the largest subsequence length that you will get if you start from 0, right? So let's just see this in action. You now are trying to find out the largest subsequence length that is starting from 3. What is the largest subsequence length that starts from 3? From 3, where can you jump? You can jump to 4. Or can you jump to 4? Answer is no, because even though the group is different, the Hamming distance is not 1. So you can't jump from 3 to 4. Can you jump to 5? The answer is again no, because Hamming distance is not 1. Finally, can you jump to 6? The answer is yes, because Hamming distance is 1 and the group's array is different as well. So from f of 3, you have just one possible jump, which is f of 6, right? Now what will be the value of f of 6? Again, you will say, I will try out all possible jumps, and from all of them I will take whichever is giving me the maximum. So from f of 6, can you jump to anywhere? Answer is no, because f of 6 is the last index. You can't jump to anywhere else. So f of 6 would be 1, because you'll say, okay, I will, like, from f of 6, if I start from 6, I will get a maximum subsequence length of size 1, right, which include only 6th index. Now you return 1 from here. So what will be the value of f of 3? It will be 2, right? Why? Because you are saying that the longest subsequence length that is possible from 6 is 1. So longest subsequence length that is possible from 3 would be 2 if you jump to 6. This is one jump and then 1 you are getting from f of 6, right? Now you got the value of f of 3. Let's just try to figure out the value of f of 0 now. So the value of f of 0 would be 3 here if you jump to f of 3, right? So if you, there are few jumps starting from 0. If you jump to 3, the longest subsequence length that you will be getting is of length 3, right? Now the next possible jump is 4. So let's just try to figure out the value of f of 4. So from 4, where can you jump? From 4 you can jump to 5, because the group array is not different, is not same, and the Hamming distance is also 1. So from 4 you will jump to 5. Now you want to find out the value of f of 5. From 5, where can you jump? You can jump to 6. Why? Because group array is different, Hamming distance is 1. So from 5 you will jump to 6. So you want to find out the largest subsequence length that will start from 6. So from 6 you already know the largest subsequence length is 1. So you already know the answer for f of 6. So what will be the value of f of 5? It will be 2, right? Basically the largest subsequence length that you will start from 6 is 1. So largest length if you start from 5 would be 2. Similarly, the largest length that we will get if you start from 4 would be 3. Why? Because there is no other path where you can jump from 4. You can't jump from 4 to 6 directly, because Hamming distance is not 1. So this is the only path, and from this path you are getting a Hamming distance, the largest subsequence length as 3. Now what will be the largest subsequence length of f of 0? If you go to 4, it would be 4. So basically if you are from 0, if you go to 3, you will be getting a subsequence length of 3. But from 0, if you jump to 4, you will be getting a subsequence length of 4. And because we only want the maximum, I will ignore 3 and keep 4 with me. Now finally from 0 there is one more choice. You can jump to 6, and f of 6 we already know the answer, it will be 1. So if you jump to 6, the largest subsequence length that you will get would be 2. Among 2 and 4, 4 is maximum, so you can simply ignore 2. Now this will be your largest subsequence length if you start from index 0. In the same fashion, you will try to figure out the value of f of 1, f of 2, all the way up to f of 6. You will take the maximum across all of them, and that will be your final answer, right? So let's look at the pseudocode. The pseudocode is exactly what we discussed. What we will do for each, let's say we are trying to find out the value for a particular index ind. So for this ind, you will iterate over all the neighboring index. Basically, the index where you can jump to is starting from ind. For each of those indexes, you will try to figure out what is the largest subsequence length if you make a jump from ind to I. So that would be 1 plus f of I. F of I will denote what is the largest subsequence length if you start from I, and 1 plus f of I will denote what is the largest subsequence length if you start from index and jump to I, right? You will just take the maximum across all of them, and that will be your final answer. Now one small thing, as we already see, we may have to calculate the same state again and again. So we have to memorize this so that we don't end up calculating the same state again and again, and hence we keep a DP array which is initially filled with -1, and we are refilling it once we have calculated the value for a particular index. So if it is not -1, we will simply return dp of index, because we already have computed the value of that particular index. What will be the time complexity? Time complexity would simply be the number of states multiplied by what's happening in each of the state, because we are sure that we will not be computing one state more than once because of this memorization technique. So number of states is simply n, because number of distinct value of index can be n. For each of these, what we are doing, we are iterating over all the next indexes. So iterating over all the next indexes will take order n into w time. Why? Because you have to actually figure out whether, like, let's say you are trying to figure out what is the next value for 0. So you jump to 1, and you have to check whether the group is same and what is the Hamming distance. If Hamming distance is not 1, you will not make this jump, right? So that's why this n into w will be required to actually find out this next array, right? Now once you have this n into w next array, you will simply iterate over all of them and take the maximum. So this is the thing that you are doing inside each of the loop, and hence the entire complexity is n square w which will pass the given time constraint because n is up to 1000 and w is just 10. Now, till now, we just computed the value of the longest subsequence length, or the length of the longest subsequence. But the problem actually asked us to find out the actual subsequence itself. Now, how can we find out the actual subsequence itself? I would encourage you to pause and try to solve this particular thing by yourself. It is a very standard if you know about DP technique. If not, you can continue. So instead, like, we know the maximum value is 4, but we need to find out what leads to this maximum value. Basically, we need to find out this 0 4 5 6 sequence. Like 0, we from 0 you go to 4, then 5, and then 6. So from 0, you are sure that you will be jumping to one index only, right, initially. So along with the largest length, let's store what we are jumping to, right? So just to reiterate this part, from 0 you can jump to 3. If you jump to 3, we saw that we are getting a longest subsequence length of 3. From 0 you can jump to 4. If you are jumping to 4, you are getting a subsequence length of 4. From 0 you can jump to 6 directly, and if you are jumping to 6 directly, you are getting a subsequence length of 2. Among all of these, one of these would be maximum, right? In this case, 4 is the maximum. So along with 4, you will also maintain what index you jumped to, because of which you got a subsequence length of 4, right? So now we are storing a second value with each value, which is what index we jumped to. Similarly, you will store this as well here. So you have jumped to index 5 from 4 to get a value of 3, right? Similarly, you will store index 6 here. From 5 you jump to 6 to get a value of 2, and similarly you store, let's say, -1 or something here, which will denote that 6 is the ending position. From 6 you don't jump anywhere, and that's where you got 1, right? Now once you have this thing with you, you can simply iterate over this thing. So you know that f of you are trying to find out what is the longest subsequence that is starting from 0. So you know the starting point is 0. Now from 0, you already know where you have jumped, 4, right? So you will say, okay, from 0 I jumped to 4. Now from 4, where you have jumped, from 4 you have jumped to 5. So you will say 5. Now from 5, where we have jumped to 6. So from 5 we have jumped to 6. Now from 6, where we have jumped to nothing. Basically this is the ending point. So this is the subsequence that this is the maximum length subsequence if you start from index 0, right? And once you find subsequence, you can simply go over the words array and uh, just take the words corresponding to those indexes and return that as the result, right? So hope the entire solution makes sense. Let's just quickly look at the pseudocode. The pseudocode is exactly similar. We are just storing one extra value here, nothing else. So instead of only result, I am also storing what is the best index, or what is the index that lead to this particular result. So previously we are doing the max of result comma 1 plus f of I. Now we will do the same, but whenever the current value is greater, basically whenever from index to I, if I jump from index to I and I know that I will be getting a larger length subsequence, then apart from updating the largest length that we can get, we will also update what is the next index that I have jumped to, right? Once you have stored all of these, you have this best next index array, using which you can actually figure out what is the exact subsequence starting from any of the index, right? Now some of you might be thinking that, okay, we actually have to find out the maximum of f of 0, f of 1, f of 2, all the way up to f of n, right? So why is the complexity n square into w? Why not n cube w, right? The answer is straightforward. Basically n square w is something we have calculated for all possible state of f, right? So f of 0, f of 1, f of 2, all the way up to f of n, all of them we have calculated in this n square w logic itself. So this loop or this figuring out the maximum across f of 0 up to f of n is something you will not have to do, or you will not have to do every time inside this loop. Whatever you have done previously, you can reuse it, and hence the complexity would still remain n square into w, right? So if you have watched to this point, I would strongly encourage you to pause and try to code this entire thing by yourself, because without coding it yourself, you will not be able to understand which part is difficult to you, and if you don't understand this, you will not be able to apply this in the future context. So hope you have tried, at least tried this once. So the code is straightforward. What we have done, we simply figured out possible next array, which is the next array itself. So what we have done for this, we simply iterated over all the next indexes for a particular index, and we just try to see what, or like all the criteria that was mentioned in the problem statement. If the criteria satisfied, we will simply push that to the current to the next of the current index. Now once we have this, we'll simply iterate over all the indexes and take the maximum value of f of x along all of them. So longest subsequence is the uh, recursive function that is denoted as f in the pseudocode. This what we are doing is, if it, like, these are the base case. If we have exhausted everything, we'll simply return 0. Otherwise, we will iterate over all the next things and take the maximum. Along with maximum, I will also maintain what is the best next, what is the index due to which I am getting the maximum, and this will be stored in the best next array. Now once we have gone through this entire process, we will get what is the longest subsequence and where it is starting from. Now once we get the start, we know how to trace back the actual subsequence. We will start from this particular index, and we will keep on going via this best next array, right? And we'll simply keep everything in the result array and return that as a final result. So hope this entire thing makes sense. If you have any doubts, feel free to post them in the comment section below. I would be able to answer. If you like the video, give it a thumbs up and to subscribe if you haven't already, and I will see you in the next one. Thank you.